Okay, so 8.1. Biggest thing we're looking at in 8.1, it's talking about relations. And all that a relation is, that's just a group or a set of ordered pairs. And inside that ordered pairs, they're going to have a couple of things that they're going to ask you to look at and break apart some different things. The very first thing that once you've got all these different ordered pairs is they're going to talk about domain and range. And the domain, that's going to be your X values. Sometimes they'll call that your input. And the range, that's going to be your Y values. And occasionally they'll call that your output. But biggest thing is, domain's always the X values, the range is always going to be the Y values. And what they're going to do is they're just going to give you some different options of ways that you can see ordered pairs, and they're going to say, all right, here's a bunch of ordered pairs, here's a relation, tell me what the domain and range are. Okay, so again, pretty straightforward. Just says find the domain and range of the relation. Okay, and there's your relation. Again, it's just sometimes 2, 3, 4, 5, could be even more than that, but it's just ordered pairs. Okay, and your domain, just go back and list your X values. You've got an 8, you've got a 7, you've got another 8, and you've got 9. You can list them in order, doesn't really matter as long as they're all listed, but the one thing is that if you have repeated values, you don't have to write that number twice. So if you've got 7 and you've got 2 8s, well, you don't have to write the 2 8s twice, just one time's enough when you go through those. And for the range, same thing. Now you're just looking for the B values. So you've got an A, you've got a C, you've got a D, and then you have a 5. Okay, and 8.1, that's pretty much about it. Now, what they'll do is they'll give you some different options. You've got this list of ordered pairs. The other thing that they'll look at is they'll give you a mapping, which doesn't look like a map. So maybe you've got a 2, 4, and a 6, and then like 9, 7, 3. And what they'll do inside of that is they'll give you some arrows that's pointed to the different numbers. Okay, and for that one, sometimes they'll label that as X, sometimes they'll label that as Y. If not, wherever you start from, that's your X values. Wherever it points to, that's going to be your Y values. So for this one, your domain is going to be real easy. It's just 246. And then the range, well, that's going to be the other numbers over here. And again, you can do it in order, or as long as you've got them listed, it doesn't really matter the order you put them in. So if you want to put it in just like they have it listed here, if you've got 9, negative 7, 3, that's fine. Okay, so for example 3, let me just give you a graph that's here and show you the other way to have these set up. Because the other option they'll give to you when you're going through these is they'll give you just give you a graph, and you have to go back and pick out the numbers. So you may have a point here. I'm going to go back and label these in because there's no way to get the numbers other than having it labeled here. Okay, so maybe you've got a graph that's something like this, and again, it'll be a little bit better defined. And if you've got dots all over the place, and basically you're just going to have to go back and kind of figure out what the order pairs are. So if you go back and list these, this one point was at negative 4, 4. This point would be at negative 2, 4. And you can almost just make a list on the side over here. It might even be easier to do it that way. The next point you've got right here is at 2, 0. This point is down at 0, negative 3. And this point is at 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. So it would be at 5, negative 5. So if they give you an order pair where it's on the graph, just go back and list off each of the different order pairs they give to you. List off each of the points, and it's still the same thing. Once you've got all the points listed, just tell me what the x values are. For your domain in this case, we've got negative 4. We've got a negative 2. We've got a 2, a 0, and a 5. And then for the range, same thing. We've got 4, 0, negative 3, negative 5. And again, the 4 is listed twice. You only have to write it once. And as far as what we're looking at in section 1, that's it. It's just, here's a list of the ordered pairs. Here's a list of what they call the relations. And from there, just tell me what the x values are. That's your domain. Tell me what the y values are, and that's your range. Okay, 8.2 still deals with domain and range. Still goes through some different parts of it. Biggest thing they look at in 8.2 is it's going to talk about functions. And definition-wise, there's all kinds of different definitions that's here. The book definition says that if you're given a relation, we say that y is a function of x if for each element of x in the domain there's exactly one corresponding y value in the range. Okay, here's what that really means. You cannot have repeated x values. Okay, that's what a function really comes down to. Function says if you pick one number and plug it back into whatever the function is you're working with, you only get one answer. You don't get two answers. You know, if you punch a button on the vending machines and you want a Mountain Dew, what happens if you get a Mountain Dew or you get, you know, a Diet Sunkist? You know, you want to know that every time you punch the Mountain Dew button, that's what you get. Functions are kind of the same thing. If you do a certain thing to it, you're only going to get one answer back. You're not going to get two answers off of it. So one of the first things that they'll do is they'll just give you just a quick set of examples, is they'll give you a list of ordered pairs, give you a relation, and they'll ask you, okay, is this relation a function? And it doesn't have to be a long list. We'll do 3 numbers here, or 3 ordered pairs. There we go. So we've got 6, 3, 4, 5, and 6, -1. And I'll say, okay, here's your ordered pairs. Is this a function? And now again, for what you're doing, you don't care about the y values when it determines functions. You're only looking at the x values. And because the 6 value repeats, then it's not a function. Okay, so whatever definitions they give to you, ever how they set this thing up and have you do all these different things for it, that's all it comes down to. It's just, do you have repeated x values? If you have a repeated x value, it's not a function. Same thing with the mappings. So you've got a mapping where you've got A, B, C on the left side and your x values, and then you've just got a 1 and 2 on the right-hand side. Okay, and you can either look at it a couple of different ways. You know, if you go back and write the different order pairs that you have here, you've got an A1, a B1, and a C2. And then your question is, if you do that, no repeated x values, correct? So when they ask you, is this a function or not, then yes, it is a function. Okay, and that's it. That's all you have to do. And again, it doesn't really matter what happens to the y values. It's only the x values that you're looking at. So, you know, they can have all 3 of these points pointing back to the same thing here. And as long as this line's not here, pointing to the 2, then you're okay. So you could have A1, B1, C1. You know, in that case, you're not even going to use a 2. If you had something like that, it's still fine, because sometimes people get thrown off with the y value. You don't really care about anything in the y value. It's only the x values that you're looking at. All right, let's give you one more mapping. Make it real quick. Okay, you've got 3, 4 in your domain. You've got 2, 1, and 10 in your range. And it should be, for the most part, they'll say, is this a function or not? And you basically either going to say, yes, it is, or no, it's not. And again, if you just think about listing off the order pairs, you've got 3, 2, you've got a 4, 1, and then a 4, 10. And because the 4 repeats, it's not a function. Okay. Now, one small thing that they'll do, actually kind of going back to the last section, With some of the questions that they'll do is they'll give you some values and have you kind of go through and list the domain and range. We didn't get that back in section, the first part there. But there was a different one that wasn't on the list here. So for this one, we'll just kind of just take a small step back for this one, back into section 1. That's a really big circle, but that's okay. Okay, and again, when you're doing these, you'll have the grid line, so you'd actually have to find the values. I'm going to go ahead and give you the order pairs just to make it work out a little bit easier. So let's say you've got a lower left-hand point that's at -3, -4 with an open circle. You've got the right-hand point at 5, 6 with a solid circle. One thing you've got to kind of go back and remember on those, if it's been a while since you've done the points, because the graphing we did for the review didn't talk about open circles and solid circles or not. But basically is this. Anytime you have an open circle, you're going to use a parentheses. And they're basically getting you ready for interval notation, which is just a different way of writing numbers instead of using the open circles and the closed circles. It's just a different way of kind of showing those. So the kind of transitions there, open circle is going to be for parentheses. And if you have a solid circle, you're going to use a square bracket. Okay, so if they give you any kind of graph like you've got for this one, all you're going to do is just take and just have to kind of look at it one piece at a time. The main values is you're looking at your x values. So your lowest value is at -3 on the x-axis. Your highest number over here is at 5. So your domain is going to go from -3 to 5. Okay, and the circles are going to tell you what to put around those two numbers. If it's an open circle like it is right here, you're going to use parentheses. Where this is a solid circle, you're going to put a square bracket. So when you use interval notation, what they're kind of previewing here in this first part of chapter 8, is that it's going to, instead of having you do like x greater than something or y greater than something where you're kind of doing less thans and greater thans, they just kind of block it off and say, all right, you can go from this point to this point. This is the values you can use, everything between -3 and 5. And then same thing for the range, you're only looking at the y values. So you find your lowest point and your highest point, and that's your two numbers you're going to use for the main range. So we started with a low of -4, the high value was 6. And same thing, because the 6 was a solid circle, close that in, this was an open circle, someone got a -4. Okay, so that's one little part that they, going through some of the problems before, they kind of sneak that one in a little bit. They get you the basic parts with the mappings and with the order pairs, and then they come back and kind of sneak this one in and talk about domain and range. I was able to catch that the last time we were teaching this class. They kind of snuck this one in with some different parts that didn't really fit with some of the other things. So that was more kind of a step back to 8.1, where they'll have you do just domain and range. And here's what we're going to do. What they're going to do then is that if they give you a graph, they'll have you pull domain and range out. At the same time, they're going to ask you, okay, here's this graph we have. Would this graph be a function or not? And to figure out if a graph is a vertical, to figure out if a graph is a function or not, you're going to use a vertical line test. And here's where you can kind of take the optimist side, or you can be the pessimist side, and we'll kind of show you both, because they say the same thing, it's just saying one thing different than the other one. Just a different angle on how you want to spin this thing. Okay, if you want to take a look at it from the pessimist side. Say it this way: if any vertical line is drawn through the graph and it intersects the graph more than one time, then it's not a function. So if your vertical line intersects the graph more than one time, it's not a function. And that basically ties in with the x values part of it. That if you, and we'll show you that here in a second, that if you have the same x value that shows up more than one time, two or more times, if it repeats, it's not a function. The vertical line test is basically just an easy way to kind of check it on that part. Now, if you're an optimist, you want to look at the good side of it. If any vertical line is drawn and only intersects the graph once, then it is a function. Okay, so the pessimistic side, you draw a vertical line. If it hits it two or more times, more than one time, could be two, could be three, could be four, whatever it is, it's not a function. If you draw any vertical line, and when we say any, you could draw 100 different vertical lines, and if every single one of them only hits the graph one time, it's a function. If you draw 100 graphs and there's 99 that don't touch it, but one time you draw the 100th one and it hits it two times, it's not a function. So it only takes one vertical line drawn through to hit it twice to make it not be a function. Okay, and we could go back to the graph that was back up here. If we scroll back up real quick. I'll just redraw it down here. And for these, you don't even have to have the ordered pairs. You just have a graph kind of like that. They can take the numbers off and say, all right, don't even worry about the numbers. Just look at the graph itself and start drawing vertical lines through it. Here you go. Draw a vertical line there. Hits it one time. There's one. There's one. No matter how many times you draw it for that particular graph, you're only going to hit the graph one time. So they ask you, is this thing a function or not? Yep, it is. That's all you got to do. Okay, somebody saying, okay, well, there's one that's not. How you gonna know? Or there's one that is a function. How you gonna know if it's not a function? How's it gonna look? And usually it's not much different. Okay, that one really easy because as soon as you draw that vertical line right here, hits it twice, right? So it's not a function. Okay, and again, if you tie that back in, here's kind of how they tie that back in to make it all kind of go together. Let's say you actually had a XY axis on this thing. And this is, we talked about this a little bit with the graphs last time. If you looked at these 2 points here and here where it hits the graph, and you actually had the points numbered out where you could actually kind of go back and see those 2 points, let's say the point up top, let's say that was at 3, and maybe this was like 4. If you drop this point underneath it, let's say that had been at like a 3, -2. Biggest thing is the x values repeat. So if you took those 2 points out, you get the repeated values. And that's really what the vertical line does. It checks to see, okay, here's all the x values that you get. If you plug in these numbers and that vertical line hits it twice, that means you're using the same x value 2 different times, but you're getting 2 different numbers back. And the vertical lines, if it's going to be a function, you should only get one answer back if you're going to go back and plug that part of it in. Okay, one other thing they're going to ask you to do is once they've gone through and kind of gone through the vertical line test with different things, they're going to talk about function notation. And basically, here's what it is. It's the same thing as an equation. They're just going to do one thing different to it. Now, and when they're talking about with the different equations, they're really kind of going back to the y equals mx plus b form when we were graphing the different parts, that you had y equals 2x minus 5 or 1/5 x minus 3 or whatever the numbers were. That they're saying, all right, in this case, instead of having y equals some numbers with x's and the y with x's and the numbers, that basically they're going to take out the y equal and replace it with f parentheses x. Now, when you got the f parentheses x, you have to read that as f of x. It's a function where your x is the variable that you're working with. If you were doing distance equals rate times time, or maybe you were talking about the speed, r would be the function you're working with, or r would be the variable you're working with because it's the rate of how fast you're going to go. So when you see the f parentheses x, you read that as f of x. That's not f times x. Okay, and then the first thing they're going to ask you to do is they're just going to give you a function, give you a table of values, and say, okay, here's this particular function. Just fill in this table of values for you. Okay, so here's the function f of x is equal to 2x minus 1. They'll give you a table of values, tell you what numbers to plug in from -2, maybe to 2, something like that. And then you'll have some blanks on the side where you've got to go back and find out what the f of x value would be for this thing. Okay, and how it is that whatever value they give for the x value, everywhere you have x, you've got to replace that x with negative 2. So where you've got this negative 2, you're going to replace x with negative 2. So over here, you've got this f of x with the parentheses. Take out the x, put in negative 2. And then here we'll plug in the negative 2. And from there, just work it out. Now, when you're doing the functions, the one thing is you do not do anything with this left-hand side, because all the left-hand side is just your directions. It's telling you, okay, you're taking x out, you're replacing it with negative 2. So once you've got this part of it, you don't do anything else with this side. So now you're just doing order of operations on the right-hand side. 2 times negative 2 is negative 4. Minus 1 is negative 5. Okay, so that's it. That's all you've got to do. It's just a different way of telling you, all right, here's the equation, plug in this number for x, tell me what answer you get for y. It's the same thing, but they just make it in a shorter, kind of condensed form when you're going through this. So over here, when you've got your table of values, just put in negative 5. And again, what you can kind of think about where you've got f of x, you can just pretty much think about that as being y. So if they ask you to graph this equation, then basically that's your order pair that will be at negative 2, negative 5. Okay, and then just keep repeating the same process. This time it's going to be f of negative 1. So everywhere you've got x, again, take out the x, replace it with negative 1. So you've got 2 times negative 1 for negative 2. Minus 1 would make it negative 3. Again, if they ask for an ordered pair answer, just would be negative 1, negative 3. Okay, and then just keep going through the numbers there. Start going through them. F of 0, well, that's 2 times 0 minus 1. 0 minus 1, that is negative 1. If we do f of 1, I'm going to run out of room here. That's 2 times 1 minus 1. 2 minus 1 would be 1. Again, order pairwise, that would be a 1, 1. And then one more. We do f of 2. That's 2 times 2 minus 1. So that's 4 minus 1, which would be 3. Okay, so either they'll ask you to fill in the table, sometimes they'll give you those values and tell you to go back and graph those points. And if they ask you to graph, just realize that the f of x is the same thing as y. And then, you know, you're plugging this number in, that's the answer you get out, that's your order pair that you're looking at. Okay, so that's kind of the first part they give to you. Now, letter-wise, they can change the letters. Functions don't necessarily have to be F. They can change those different letters and have you all kinds of different numbers. They could tell you to do something like this. They may say that, all right, let's say that g of x is 2x squared plus 3. And they may tell you, all right, find g of negative 4. Something like that, maybe. Okay, now, biggest thing I can say when you're evaluating these, make sure that whatever number they give to you, if they give it to you like this, where they've already told you to find g of negative 4, which is just one number, make sure you always put parentheses around that number when you're plugging it back in. Because sometimes people get a little bbit, I won't say they get a little bit lost, a little bit confused, but sometimes if they don't put those numbers in parentheses, if you just put this, if you don't put the numbers in parentheses, people get lost because they're like, all right, well, what am I doing here? Am I doing 2 minus 4? Or is that 2 negative 4? So if you go back and put this negative 4 in parentheses, when you plug it in, it helps keep everything going. Because the only thing that can be inside the parentheses is that negative 4. Everything else has to be on the outside of it. And now you're back to basically just, 7th, 8th grade math when you're doing order of operations. So you've got multiplication and you've got exponents, so you got to do your exponents first. So do negative 4 squared to make that 16. So then you've got 2 times 16, which would be 32, plus 3 would be 35. All right, and again, don't do anything with that left-hand side where you've got g negative 4. That's just saying, all right, we just took this one function, we plugged negative 4 into it. Don't ever do anything with it. You're really just working out the right-hand side of those different functions that's there. Okay, so the letters are changed, and sometimes they may even give you some parts of it where they just have you plug in another number. They could have taken this same equation that was here, and they may just say, all right, find g of y. And if you do that, the only thing that's going to happen is instead of having x in your answer, you're just going to have y in your answer. So that's 2 times y squared plus 3. And they're just trying to get you comfortable with knowing that you can plug in anything to this part of it, and just figure out the different parts that go with it here. Okay, then they kind of throw one thing at you called a step function. Now, in this case, they really don't even get too deep into it. It's more of just, it's almost like a word problem. I know y'all don't like word problems, but we'll kind of throw this out here so you can just kind of see. It basically looks something like this. May say something like this. A car uses 1 gallon of gas for every 25 miles driven. And they'll ask you, okay, how many miles can it go on 4 gallons? They call it a step function. They try to make it out to be something bigger than what it is, but it's really pretty straightforward. If you can go one gallon will go 25 miles, well, just going to do 25 times 4, right? So you go 25 miles on 1 gallon, you go 4 gallons, that means you're just doing it 4 times. So 25 times 4, there you go. There's 100 miles. So they call that a step function. That's really not exactly how you would do a step function, but that's kind of the way they set it up. If you were really doing a step function the way it's supposed to be done, it's supposed to be, and you don't have to write this down, it's supposed to be one of those things that you start at a certain point and then you end at a certain value, and then to get the next thing, you just jump to the next value, and then you would jump to the next value. And miles per gallon is a little different because it's not like you use 1 gallon and you jump 25 miles. It's more like parking. If you go to, parking a parking deck, and a lot of times it's $1 for the first hour, it's $2 for the second hour, $3 for the third hour, and if you stay all day long, doesn't matter if you stay 4 hours or 8 hours, it's $4. So it's almost like one of those things where, the first level, this is $1. The next one, this is $2, and maybe it's $3 or $4 to stay all day long. So it's one of those things that if you stay an hour and 30 minutes, you don't pay $1.50. If you stay an hour and 30 minutes, it's $2. If you stay an hour and a minute, it's still $2. An hour and 59 minutes, it's still $2. There's no in between. You just jump from one level to the other. That one, really, it's not a good example of a step function, because if you drive, if you have 1.2 gallons, you get to go a little bit farther. So they set it up like a step function. It's really not a step function. It's just that's what they call a step function here, but it's really not exactly set up to be the right way. But that's, in the homework, that's where they kind of throw it out there too. Okay, so they'll give you some different little equations and have you kind of plug in some numbers on those. Oh, here's the other thing they'll do to kind of tie in with that one. Sorry, let's do it this way. Instead of the equation, we're going to make it a function. You're given the function. Again, they just start throwing out different numbers, different letters at you when you're going through this part. And maybe it's L of D, and maybe it's equal to 135 minus 5D. They may ask you to then find L of 17. And mostly I think they're just getting used to knowing that there's different numbers. They'll try to throw in some word problems, but at the same time they'll give you the function at the end of it. So you can just kind of not even pay attention to the word problems and just look at the function and see what you got here. So just plug in the 17. That's 135 minus 85. So that part would be 50. Okay. And then the one thing they might do to kind of make it a little bit different is they may ask you, okay, what value of D would make the function equal 0? Okay, so if they go ahead and tell you that the answer is 0, then basically you can just take this 135 minus 5D and just let that equal 0. So they'll go ahead and tell you what the answer is. So it's kind of one of those where they kind of go the opposite of it. If they tell you that the function is equal to 0, they're telling you what the answer is, and now they're saying, all right, work this thing backwards and just tell me what makes this thing equal 0. So you just take the 135 minus 5D and let that equal 0. Or if they tell you it's 10 or whatever it is. So that should be pretty straightforward when you're going through that one. So for that one, I'm going to subtract the 135. So we've got negative 5D equals negative 135. Divide both sides by 5, or the negative 5. And that should come out to be 27. Okay, but the big idea they're trying to get you to get with all the functions is whatever the function is, no matter how they've got it written, they're going to give you a value to plug it back in. Occasionally they'll kind of word it where it's a little bit set up different, where they tell you, all right, we need this answer to be 0, or we need this answer to be 10. Now tell me what you got to plug in for D. That D could stand for days, or it could be, for donuts when you're going through that. Oh, and remember, Friday, Krispy Kreme has chocolate glazed donuts out again. If you're listening to this online, just ignore that part. If you're listening to this recording. Okay, so here's one function that they'll give to you. And it's a graph where they've got, now this part, they may ask for domain, they may ask for range on some different things on this part. So we'll kind of answer just a bunch of different questions. But here's one where they'll kind of go in reverse, that they'll ask you to, they're going to ask you to evaluate the function. There's not an equation, so you don't really have an equation with this one. They're just going to ask you, okay, let's ask you to find f of 3. And again, there's no equation, all you have is the graph. So for this one, basically what you have to do is, if they tell you that you've got to find f of 3, it's almost like an ordered pair, that they're asking, okay, if you have 3 as the x value, what's the y value going to be? So basically you've got to go through this graph, find the point where you've got 3 on the x-axis, and just kind of look up and down till you hit the graph. Well, that's this point right here. And that point would be a 1, 2, 3, 4, 5, 6. There's that point, 7. Okay, make the point a little bit bigger. So if you drop this point down, it's at 3, negative 7. So they ask you to find f of 3. Well, then your answer is negative 7. So when they give you graphs like this, that's kind of what that's kind of the way they'll kind of turn this to be a little bit different. Is without the equation, they're saying, all right, here's the x value of the ordered pair. Find out what the y value is of that ordered pair that's somewhere on this graph of this thing. So you can find another point. Let's give you something else here. Let's do f of, let's see, what would be another point that would be good to find here. Let's do f of negative 1. Okay, so as far as ordered pairs go, they're saying, all right, we've got an x value of negative 1, so find the ordered pair that's at negative 1, and basically go to negative 1 and go up until you hit the graph, or go down until you hit the graph. So if you go to negative 1 on the x-axis, that's right here, you've got to go up to this point, which is right here, and that points up at positive 1, so for that answer, that would just be a 1. So if they give you a graph like that, you're basically just trying to figure out exactly, here's the x value, move until you go up or down until you hit the y value that would be on the graph of that line that you're looking at. Okay, and here's where they'll kind of go in reverse on these. So then they'll kind of reverse it. Now they'll say, all right, for what value or values of x is f of x equals 0? Okay, so now it's basically the opposite. This time you don't know what x is. So they're saying, okay, find the points where you've got a y value that's 0. The y value is 0, meaning you don't go any up or down, you just stay right on top of the x-axis. So if you do that for this one, you've got 1 point here, 1 point here, and 1 point right there. So then tell me what those x values are. Well, if we start on the left, that's at 1, 2, 3, 4. That's at negative 4. The next one's right here at 0, 0. And the next one is at 1, 2, 3, 4, 5, 6. So there would be your three values that would make the y value, in a sense, be 0 for that thing. Okay, and then here's where I'll kind of go back and give you another graph like this and ask you to do domain and range. And we'll look at that just so we can make sure that it's not doing anything funny. Okay, now domain on this case. Again, with a graph like this where there's nothing really listed, you're looking at this part as, okay, if I'm on the x-axis, how far to the left can I go? And if this graph is pointed down, now it goes forever. So even though it's going down, it's still going down to the left, so it's going to keep going forever off in the left direction. So for that thing, you'd be going from negative infinity. As you move to the right, there's your stopping point right here at this point, and you're looking along the x-axis, so this is at 1, 2, 3, 4, 5, 6, 7, 8. That stops at 9 on the x-axis. And that's an open circle, so you put a parenthesis there. Okay, so the domain, you're basically looking along the x-axis. When they ask for the range, well, now you're looking along the y-axis. So now you're looking up and down and not left to right for this part. Okay, so if you start for the low part, you've got a low point right here, but this line is still pointed down. So it's kind of the same thing for this one. It'll keep going down forever. So your range would be negative infinity. And then you look for your high point. Well, you've got a high point here, but you've got a little bit of a higher point here. And on the y-axis, that's at 1, 2, 3, 4, 5. And same thing. That one's got an open circle at that point, so that would just make it go from negative infinity to 5. Okay, so that's where they'll take it from just an equation where they have you just talk about domain and range, and here's the parts of it. Here's where they'll actually do the function part, where they give you some values to plug in to kind of work through and find the different parts of either giving you an x value and have you figure out what the y value would be, or they give you the y value and ask you to find out what the x value is that would kind of match up with it there. Okay, now one little thing that kind of goes with that one, and we'll kind of do this as a separate piece here. They're going to talk about an x-intercept or a y-intercept. When they talk about an x-intercept, that's where the graph crosses the y-axis or the x-axis. Okay, and the one thing about the x-intercept is if it's where it's crossing the x-axis, the y value is always going to equal 0. Okay, and if they talk about the y-intercept, well, it's just the opposite of that. That's where the graph crosses the y-axis. And the one thing that's always true about any point that's on the y-axis, that means your x value is always going to be 0. And you may have more than one, depending on how the graph is, you may have more than one. And that's basically, if we scroll back up real quick, that's basically when they ask for this part right here which said where f of x is equal to 0, that's basically saying, all right, what's the x-intercepts? We crossed the x-axis here, here, and here, and just tell me where those points are. And that's basically what that was we were doing for this part. So if they ask you for the x-intercept, it's just where the y value is 0, which is where it's hitting the x-axis. Okay, and then finally in the last little part of section 2, they kind of go all over the place with section 2. The last thing that they do, which doesn't have anything to do with graphs necessarily here, is they're going to ask you to, a couple of things here. They're going to ask you to find the excluded values. And we did excluded values in the last chapter, didn't we? I think it's something else. Didn't we do that? Okay. So and they kind of come back and do the same thing with these. Is they're going to ask you, now the difference is instead of it being y equals, it's going to be f of x equals. So you've got x plus 3 over x minus 2. It's still the same thing. It's still your denominator equal to 0. So you're still going to take x minus 2, let that equal 0, and exclude that value. So add 2 to both sides. So we're going to exclude x equals 2. Now, here's where they might bring in interval notation with this one to kind of bring it back in. Now, you're not going to have to graph that, because that's a different kind of graph that we're not going to look at. So they may tell you, all right, you're going to exclude x equals negative 2, or x equals 2. They may also kind of give it to you as one option that you could put. They may say something like x cannot equal 2. Anything other than 2, and we're fine. So there's one option you can do. Here's like the second option. Because they may say, all right, you've got to exclude x equals 2, which is the same thing as saying you can use any number in the world you want to use, you just cannot use 2. And then the third option is where they're going to use interval notation again. And if you can use any number in the world you want to use except for 2, they're going to say, all right, basically you're starting at negative infinity, and you can use any negative number you want to use. Doesn't matter what it is. You can go to infinity. You can use any number you want to use, but we have to skip over 2. So what we're going to do is we're going to say we're going from negative infinity to 2. Put a parentheses there. And then we're going to start back at 2. And left too much gap there. And then we're going to go from 2 to infinity. And if you skip over one number where you're kind of combining two graphs, or you leave out a section of it, you just put a U in the middle, and that says that U is like the union. It's taking the first part that you have and combining it with the second part. There'll be a part a little bit later on when we actually dig into interval notation a little bit more, where we'll do an upside down U, talk about what that is. But for now, that's all that we're looking at. Okay, so give you a fraction problem where they have you go back and tell me what the excluded value is, and then usually the next problem is after that, we could take that same function that we had there, x plus 3 over x minus 2. And then they say, okay, now you're going to find let's go f of 9. Okay, so finding f of 9, take out the x and replace it with 9. So it's going to be 9 plus 3 over 9 minus 2. Now, and you can put the parentheses around that one if you want to. There's really nothing else going on with the x. It's just x plus something, x minus something. But if you get in the habit of doing it, go ahead and do it there. So you've got 9 plus 3 for 12. 9 minus 2 for 7. Nothing you can do to simplify 12 over 7. You don't have to change it into a mixed number. Just leave it as a fraction. You're okay. Now, if it can simplify, go ahead and do that. But in that case, there's nothing you can do to simplify that kind of problem. So just leave it as 12 over 7. Okay, now here's where they step it up one more notch from the excluded values we were doing back in the last chapter. Here's where they step up excluded values one more notch with this one. Actually, hang on, looked at that wrong. They're still going to have you to find the different values here. So I'm just looking at my example here, kind of misread it. Let's go with x minus 8 over x squared plus 13x plus 36. They're going to ask you to find f of negative 7. Okay, so same thing for this one. But when you're going through the different parts of it here, you're just plugging it in. So you've got f of negative 7. You've got negative 7. You can put that in parentheses, even though it doesn't really do anything there. Minus 8. That's over negative 7 squared. Plus 13 times negative 7, and then plus 36. Okay, so from there, just simplifying the two parts. You've got negative 7 minus 8 for negative 15 on the top. The bottom part, that's where you've got to put the work in. You've got negative 7 squared. Well, again, for the negative 7 in parentheses, it's negative 7 times negative 7, so that's positive 49. You've got 13 times negative 7. That's a negative 91. And then plus 36. The negative 15 on top, nothing you can do with that. So from there, it's just working out the bottom part. It's negative 15 over 49 minus 91. That is negative 42. And then plus 36. If we do negative 42 plus 36, that is a negative 6. Okay, so here's one where we've got improper. Now again, that part, there is actually some simplifying you can do. First thing is you've got the two negatives, so that's going to make it a positive. But you also have 15 over 6. You can divide both of those numbers by 3. So 2 negatives makes it a positive. That's going to make that 5 over 2. And that's the answer you're looking for there. So it's still evaluating. They just give you a more complicated problem to plug in and work through it. Okay, and then the last thing. Here's one where you actually have to, this is where they're going to go back and talk about the excluded values of an equation, like something like that. Now here's where they're going to change the wording. A minute ago we did where it said list exclude values. This one they're going to change the wording, but it's still the same thing. They're going to say find all values of x that are not in the domain, which is still another way of saying tell me what the excluded values are. And again, the biggest difference is this time, instead of last time we looked at where everything it was just x plus 2 over x minus 8. This one, they're going to bump up the values just a little bit. So now we're looking at something like this, where we've got f of x is equal to, let's go with x plus 9 over x squared plus 18x. Plus 81. Okay, so they say the wording of it a little bit different in this part. Find all the domain, find all the values of x that are not in the domain. It's still the exact same thing. You just got to tell me what you're going to exclude. So we're still going to exclude x squared plus 18x plus 81 equal to 0. Different wording still means exact same thing. Okay, now I can't remember if we mentioned this last time, but if you start solving equations and your highest power is x squared, why is this not highlighted? There we go. Yeah, pen's not working. So if your highest power is x squared, that means you're looking for two answers. Whatever answer you start with, whatever power of x you start with, if your highest power is x squared, you need two answers. When we did the other one up here a minute ago, we started off with x minus 2, that's x to the first power. We had one answer. So in this case, if we start with x squared, now you're looking for two answers. Okay, biggest difference on this one is that with it being x squared plus 18x plus 81, they're going back to the factoring part, that you've got to find the factors of 81 where the sum is going to equal 18. Now they're all positive, so that makes that one a little bit easier. Of course, it's not 181, 3 and 27. The next pair of numbers that works is 9 and 9. Seems like there'd be more than that, but for the most part, that's about it. So there's your pair of numbers right there. So you've got x plus 9 and you've got x plus 9 equal to 0. Now, with this one, because they're the same number in the parentheses, we are going to get two answers. They're both going to be the same answers because it's the same set of numbers in parentheses. So when you do the x plus 9 equal to 0, that means we get x equals negative 9. So that one kind of a trick question because the negative 9 was the same in the parentheses. The first parentheses, it would also be the same as the one in the second parentheses. So we had two answers. It just happened that both answers were negative 9. So we'll just have to say that in that case, we're going to leave out x equals negative 9. Okay, and that one they're not going to ask about the way it's worded. They're not going to ask you about interval notation for that part. They say find the values. That's not in the domain. So it's just x equals negative 9.